So the game, it's a popular game actually, but never thought about this way. I don't know if somebody has thought about it this way. I decided to do it this way. And I've decided to do it saying say a word that begins with the letter of the alphabet. In math, a mathematical word that begins with the letter of the alphabet. For instance, I'm going to do for English. If I say English. Sorry. Sorry about that. Okay, so if I say for instance, in English, A, adverb, B, because, C, comma, D, determiner, for instance. So let's all unmute and play this game. First to say any word, really, it has to be relating to math. From A, we're going to go from A to Z. I tried to play it by myself. I got stuck with some alphabet. So let's see if the rest of us can get it. Are we ready? Unmute, everybody. Unmute. Are we ready?
Yes, we are.
Miss Amaka, unmute. Hey, Miss Faith. Miss Ursula, unmute. All right. A.
Algebra.
B.
Bracket.
C. C.
Calculate.
D.
Divide.
E.
Estimate.
Estimate. Element is in science. Estimate. F.
Fraction.
Figures.
Figures. Fraction. G.
Geometry.
H.
Height.
I didn't get that one. I.
Inequalities.
Oh my, why did I think of that?
Indices.
Oh, J. I was talking that one too. I was talking J to J.
Joint variation.
Okay. Yeah, that's
K.
Kilogram.
K. L.
Kilometers.
L.
Line.
LCM.
Lines and angles.
LCM.
Medium. M.
Multiply.
What is itself? M.
Numbers.
O.
Odd numbers.
Odd numbers.
As for me, as it open sentences, odd numbers, correct. P.
Percentage.
Place value.
Percentage. Do you know all I could think of was pi? Q.
Quadratic equation.
Q.
Quadratic equation.
Quadratic equations. I could think of letters. MNOPQR.
Ratio.
MNOPQRS.
Roots.
Sum.
Subtraction.
T.
Triangles.
Tangents. I thought of tangents. U.
Times. Unit.
Units. Wow. V.
Variables.
Volume.
Volume. Venn diagram. V. W.
Word problem. Word problem.
Waffle diagram.
Whole numbers. UV. UMNOPQRS UVWX.
We have
X-axis. X-axis on the
and then Y-axis.
Z.
Zero.
That was fun. That was interesting. Thank you all for
Yes,
playing. You know,
it was.
sometimes we are too serious with math. You know, we can actually have fun with children having this. It's like kind of like um an icebreaker, especially if you're starting to teach a new class. Okay, so thank you all for playing. Now, I'm going to introduce our guest, our speaker for today. This is Faith Oluebube Okoye. Faith Oluebube Okoye. Now, she is somebody that um I'm trying to use the word because I know she's laughing right now and eager to listen to all I have to say. But first of all, she's my daughter's teacher. Okay, and my daughter is not so keen on math, even though I do teach math. She's not keen on math. However, she's able to go around math easier than she used to. So, and I know it's not me. It's not me. I didn't do that because as a parent, at a point I had to stop taking them one-on-ones. You know how we could be as parents. However, Faith is somebody that she's proactive. She she's somebody that solves problems, not just mathematical problems, but literally. She sees a problem, she tries to solve it. She's focused. Kind of, I sometimes I look at her, it feels like her brain is always calculating. And then one thing about her, one day she saw me eating. We work closely together now, and I didn't know she used to follow me online until weeks after we met. She came and you did true confession. And then one day she saw me eating and she was kind of surprised. I said, "What? I eat?" She said she thought I lived on air. I didn't use it. Anyway, Faith is somebody that is dedicated to teaching and for teachers, for children to learn. Miss Ursula, you're laughing, but honestly, it's baffled me. I think I made a post on that one time because there is a lot of things that she kept enumerating. I was like, this chick, I'm just human. And she didn't, some things I surprised her in a lot of ways. One thing she was surprised was that I had humor. I played a lot. She didn't see me that way. And that's because she's not in my close community, so she doesn't see me when I play. So, and she has only seen me when I came out to train, went to speak at events, and where I was called in teachers for one or two things. So, Miss Faith is somebody that I trust. If I trust her with my child, so I believe I can trust her with encouraging children, teachers to teach to their best abilities. Thank you, Miss Faith, for doing this. Over to you.
Thank you very much, Miss Raina. I was just laughing when you were making the introduction. Thank you so, so much. Okay, let me just add to that. I have known Miss Raina for years now, and before I started working closely with her, I've attended a lot of training where she was part of the spokesperson. I knew a lot about her, especially the career, what she, the educational part and all of that. But I never really got to know her closely. So when I did, I was just, surprised by the so many other things that she can do. All right, thank you very much, Ms. Raina. Thank you to everyone here. Thank you for coming. Thank you for being part of this meeting. Okay, so our focus this evening is teaching mathematics in Key Stage 2. Teaching mathematics in Key Stage 2. I believe all, if not, most, if not all of us here are mathematics teachers. So I'll just go ahead now and share my screen so that we begin.
I had made you a host before, I think on the other.
Okay.
Let me make you again. I made you a host on the other device.
Oh, okay.
I think you went out of it. So let me make you a host again. Oops. Sorry, I touched something. All right, done.
Okay.
I see my people here. While Miss Faith is getting herself ready. Thank you, Mr. Yusuf, for joining.
Okay. Can we see my screen?
Ma'am, thank you for joining. Yes, I can see your screen, Miss Okoye. Yusula, this lady. Never
Okay, all right, let's begin. So our focus, like I said earlier, is teaching mathematics in Key Stage 2. And in this session, we are going to look at what Key Stage 2 is all about. Then we'll talk about what teaching math in Key Stage 2 should be like. We'll briefly go through the CPA approach, although the speaker for yesterday spoke extensively on that, so we wouldn't waste so much time on it today. And then we also take a look at how to get children of the 21st century to learn and love mathematics. I remember the speaker yesterday mentioned extensively about, oh, sorry about that. I remember the speaker yesterday mentioned extensively about why a lot of children in this 21st century do not like math. Yeah, then we'll also take a look at why learners forget and how we can help learners to remember better. And of course, we'll talk about how to help pupils or learners comprehend word problems and improve mathematical accuracy. Are we ready? If we are, can I see a thumbs up? All right, thank you very much. What is Key Stage 2 all about? Key Stage 2 refers to learners between the age of 7 to 11 years, that's years 3 to 6. And then at this stage, pupils are expected to develop mathematical fluency in number work, in reasoning, in problem solving, in the application of mathematics to real life situation. And that is where a lot of students tend to miss it out because they all believe that math is not relatable to anything they do out there. I remember the speaker for yesterday also mentioned in some parts of our training that now as an adult, she's wondering where and how some of the things she was taught back then has helped her in life, how it has helped her in life. Okay, the key areas for children in this age grade includes number, fraction, measurements, geometry, statistics, and algebra. I think fraction should have been number 1, but number is still number 1 regardless. All right, so what should teaching mathematics in Key Stage 2 be like? What should teaching mathematics in Key Stage 2 be like? Especially for children in the 21st century. First of all, it should be child-centered. This shouldn't even just be mathematics. It should be any subject at all. Whatever it is that you're doing as a teacher should be child-centered. Okay, pupils should actively participate rather than just sit and listen while you do the talking as a teacher. Of course, it should be practical also. You should know how to use manipulatives such as counters, number lines, fraction strips. You should learn how to use everything in the classroom environment as an instructional material. Make learning relatable for children. Thirdly, it should be interactive. You should encourage discussion, questioning, and group work. When I say encourage discussion, I mean stimulate the children to think, okay? It stimulates them to think. You know, there is this levels of question where we have the LOT and the HOT. That's the lower order thinking and the higher order thinking. So you should be able to move children from LOT to HOT as a teacher. And like I said earlier, whatever it is you're teaching should be relevant. You should know how to connect mathematics to everyday experiences, such as shopping, sports, or time management. Okay. I remember last week, was it? I was taking data collection and presentation, and then I just turned the classroom conversation to, okay, take data of the number of girls we have in class, the number of boys we have in class, those that measure, let's say 1.3 meter as height, or those that measure 7 centimeters, like that. So we measured each and every one of them, and the children represented it all in a tally table, in a frequency table. This is what I mean when I say your math class should be relatable, okay? And of course, it should be inclusive. You should be able to support all learners through differentiation and scaffolding. I believe we know what differentiation and scaffolding is all about. Differentiation is grouping learners based on their learning ability, okay? So that you don't have the slow learners missing out when the fast learners are catching up. If you have a group of 7, 10 children and 8 of them are catching up, they are really responding well to what you're teaching. What happened to the remaining 2? They miss out. So you can differentiate the children, put the fast learners, the middle learners, and the slow learners in groups so that you're able to meet each set at the point of their need. And scaffolding is all about giving support when you start to introduce a concept. And with time, you withdraw the support and let the children work independently. So the aim of all of this is just to build understanding, confidence, and a positive attitude towards mathematics. Okay, we have the CPA approach. I'm just going to run through this very quickly. C is concrete, P is pictorial, and A is abstract. This approach helps learners to develop deep mathematical understanding, okay? They are able to go from what they know, what they didn't know into what they know, and they go from what they know into thinking abstractly, all right? In the concrete stage, you use physical objects to perform mathematical operations. You could use counters, cubes, and fraction strips. In the pictorial stage, In the pictorial stage, you represent ideas through drawings, diagrams, and models, okay? And pictures generally helps concepts to stick better in the mind of children. After you have taught them, okay, let them draw a table and represent this in it. Let them try to, you could also show them pictures and let them practice, let them discuss what they see in the pictures. And when it comes to abstract, now they are used to performing those operations without any pictures, without any counters or cubes or whatever hands-on material. They're able to think on their own and give you the results. Let's say, for example, you want to teach the children how to perform 4 times 3. You can first of all use counters where they count 3 groups of 4s and then they count it all together. And then you could make it pictorial, ask them to draw. You could use strokes, they could use circles or whatever objects they want to draw to make the calculation. And then finally, you can ask them to just multiply it. 4 times 3 gives what? Yes, like that. Can I see a thumbs up if you're following? All right, thank you very much. How do we now get children in the 21st century to love mathematics? How do we get these children that are impatient, these children that find mathematics boring, these children that feel math is hard and irrelevant to whatever they will do when they grow up? Because a lot of them would actually ask you, I want to become a doctor. How will this help me to become a doctor? I want to become this. How will this help me to become that? These children think, they are very, very smart, smarter than we actually think they are. All right. So teachers can increase student engagement. Teachers can increase student engagement by using technology and educational apps. You could use technology and educational apps. Okay. We have quizzes, we have Kahoots, we have all of that. And you could even ask them one day, okay, bring your laptops to school. And then we are going to do all our calculations today on Microsoft Excel. You teach them how to just do basic operations on that. They just love it when you bring in things that they love into the things that you do not love. I remember yesterday in the training yesterday, Miss Raina asked a question. She said, when a child is so uninterested in mathematics, and how do you get that child to like math? When the child keeps telling you, oh, I don't like math, I prefer this or that, how do you get that child to like math? I wanted to answer that question yesterday, but I said, let me reserve my response for today. Okay, if I was in that situation and I have a student like that, here is what I'll do. I'll ask that child what they love, and then I'll leave whatever mathematics I have in my mind or decide, and we'll discuss what that child loves. Then as I'm discussing with that child, I find a way to link what that child loves into mathematics, because there's always a linkage between math and other subjects. Okay. All right. Then you can incorporate games and challenges. All right. There was this time I was teaching long division. That was last year to my learners. And I realized that a lot of them don't like long division. They prefer the short way. I taught them both of them. Okay. Then I divided the class into 4 groups. We had a mathematics competition. I had prizes, a notebook, a pen, and a pencil as the prize for the best person in each group that would perform the best. Then I drafted a lot of questions. I think there were about 50 questions I used, all on division. And I said it must be solved using long division. Now they had no other choice than to go and learn long division because they want to win. And then I made it a competition. I timed the challenge and all of that. And it was so fun and engaging. And since then, I don't think they've had issues solving division again. So we could do things like this. You can incorporate games and challenges, all right? It helps learners to want to learn more. They want to learn that thing because they want to perform the best. They want to be the best in that game. And of course, you link mathematics to real life situations, okay? There was this time I was telling my learners that I play Roblox, and they were all surprised, like, Miss Faith, you play Roblox? What are you doing there? That's for children. I'm like, yes, I play Roblox too. And before I knew it, I started engaging them in games in Roblox and how the whole thing works. Now, they were so interested in the fact that Miss Faith, their teacher, plays a children game. So these things can help them love mathematics. They make your classes more interesting when you engage in conversations that they like. Okay, but of course, as a teacher, you should be able to streamline the playtime and the serious time. Don't let them use, because when you start this conversation, they would give you so many comments, so many opinions. Don't let them use the entire learning time for just discussion. You're just trying to buy into their own world and let them know that, okay, I am in there also, and math is not all that boring. You tell them how math is used in that kind of situation. You could also tell them, ask any of them if they've ever attended the birthday party before. And if, of course, they would have. When they raise their hand, you not tell them, oh, how do you think that cake was made? How do you think the organizer of that party was able to know that, okay, 50 children will be coming, and then they planned party packs? If there were 5 items inside each child's party pack, and there were 50 children, how many items do you think that party organizer bought? That is mathematics playing out in things that they love. And these kind of things will help them to think abstractly. Okay, they're able to relate everything they've learned in mathematics in real life situations. You can encourage investigation and discovery. I'm that kind of teacher that after I teach every concept and I realize that my students have gained 50 to 60% of mastery, I throw a question that is harder than what I have taught them to them. I call it genius question. And I ask them to go and research, go and solve it. And of course, when you're coming to give me my answer, you present how you were able to get your answer. I'm sure Miss Rahina's daughter would have, brought 1 or 2 of those my questions to Miss Rahina.
Definitely.
All right, thank you. So these kind of questions challenge children. It makes them want to think. And trust me, children love it when you give them problems to solve, okay? They love it when you give them problems to solve. Let me also say this thing. As a math teacher, don't be so quick to solve problems for your children, okay? There was this time, I think that should be about last term, I gave a question on ratio, yes, to my students. And then a particular student was trying to divide 810 over 54. I know 54 is the number that once you divide it once, you get an odd number. And if you're not good with odd numbers, it's going to be quite difficult for you to arrive at an answer. And then she struggled and struggled with it. And then she brought it to my table and said, Miss Faith, I'm not getting this thing. It's frustrating me. I smiled at her and I told her to go and try, figure it out. There are so many ways to solve mathematics. Use another method. Do you know what this girl did eventually? She added 54 plus 54 plus 54 to know how many 54s. You give her 810. Now, that stressed her. But with that, she's able to still solve the problem, okay? But imagine if I have just come to her aid and tell her that, okay, when you divide the first time, you have a 27, you could use 3, you could use 9. That is me helping her to solve the problem, which is not bad, okay? But when I ask her to solve and try what she can, try all possible methods that you can try, she's able to know that she's able to build her problem-solving skills Okay, she's able to build resilience in mathematics, because I always teach my learners that there are 1001 ways to have a mathematics problem solved. Okay. Another way you can get the 21st century children to love mathematics is by promoting collaborative learning. Okay. Group them into groups of, say, 4 or 5. Give them a task to solve. Okay. Let them work together. Let them bring in ideas. There was this time I finished having a test with my higher class learning class, that's grade 6. Then I picked one of their test questions to my grade 5 learners, a math question. I just gave it to them, all of them. They should work together and solve it. I've not taught them the topic. They have no idea of what the topic is about. Do you know what these children did? They went to a grade 6 learner, collected their math textbook, came back to class, searched for the topic, and started studying the topic. And they were able to solve the question eventually. So let these children understand that there are so many ways to solve math, okay? They can do whatever it is, that they can work together, share knowledge. That idea of going to collect a grade 6 math textbook came from one person and others bought it. They all searched, they shared knowledge, they put their heads together to have that question solved. Now, these are ways that you increase the interest of children in mathematics. Of course, you should celebrate effort, progress, and creativity, okay? There is something that is a rule in my class, my math class. Whenever I give a task, an assignment, test, or anything at all, I always clap for those that had a perfect score. Let's say it's a test of 5 questions. Those that had a 5 out of 5, we clap for them. Those that had a 4 out of 5, we clap for them. Now, these things helps children feel seen. It helps them to know that, yes, my teacher knows that I am improving. And please, as a math teacher, be that kind of math teacher that would always celebrate progress over performance. Okay, if you have a child that's always acing your math test or math tasks, encourage that child. Yes, that child is doing well. But then you have a child that is used to scoring 30 out of 100, 30% out of 100, and then all of a sudden that child made it to 50 out of 100. Please, especially celebrate that child, okay? Because it helps the children to feel seen. It helps them to feel that, yes, my teacher knows that I'm improving. Unlike when you celebrate those that had a 95, 95, 95 all the time, and the one time they had a 96 or a 92, that child is still circulating around A. But that child that has moved from C to a B, or that has moved from a D rather to a C, is worth celebrating specially. Right. If you're following, can I see a thumbs up? Thank you. Thank you very much, everyone. Okay, now to the interesting part. Why do learners forget? Why do students forget when we teach them? There is what we call the Ebbinghaus forgetting curve. Okay, it was developed by Hermann Ebbinghaus, and this curve shows how learners forget things gradually. Okay, they forget information over time if it is not reviewed or practiced. Okay, forgetting occurs most rapidly soon after learning rather, and decreases as the information is reinforced. Okay, let's put it this way. In week 1, you have taught basic operation, the 4 basic operation. The child has learned that. In week 2, you're teaching place value, for example. In week 3, you're heading on to fraction. By the time you get to week 5, you'd realize that what you have taught that child in week 1, the child has forgotten it. And sadly, this is the case for most math teachers, because already children don't like math. Most children don't like math. Okay, so if you're not very careful, you're going to just end up pouring water on rock, and the water won't sink deep, it won't sink in. So how do you now deal with this as a teacher? Let me digress a little bit. In psychology of learning, okay, there's what we call stages of memory, stages of retainment in the memory. We have the short-term memory as human beings, and we have the long-term memory, okay? If someone tells you something immediately, that information is stored in your short-term memory, okay? And if something else takes your attention, that information is going to be lost in a time as short as 1 second. That is why sometimes you're holding your phone in your hand and you're busy searching for your phone. That is why you'll be having a conversation with someone in your presence, and then you receive a call. And then after the call, you are finding it difficult to remember what you were saying with that person. That is short-term memory. Whatever information is retained in short-term memory. Okay. And I believe we all also experience this situation in classroom where you give a child, you teach, right? After teaching examples, you give class task, a child gets the class task, then you give assignments, that child gets home and has forgotten how to do the assignments. And then the child will now return it the next day and say, oh, I didn't understand, because that's always the word they use. Is it that they did not really understand, or they have forgotten how you taught the concepts? Because if you pick up their maths notes, you see that they got their class task right. And then you will now be wondering, if you didn't understand, how were you able to get this in class? That's because that information for that child was stored in short-term memory, okay? Now, as math teachers, you need to learn how to move information in the brains of children from short-term memory to long-term memory, okay? And how do you do this? Next slide. You can do this by using regular revision, okay, on previous taught concepts. You don't just teach a topic and let it stay wherever you have taught it, no, and say, oh, I must cover my curriculum like the yesterday's conversation we had. No, you should be more after how much these children have learned and how much they are able to remember, okay, because what they're able to remember is a proof that you have taught. If you teach a child and they're not able to remember in the long run, it's as good as you just poured water on a rock. That learning didn't actually occur. Okay, so you use regular revision. In week 5, you can still throw a question from topic you taught in week 1 or week 2. Okay, you should be able to apply spaced repetition, revisit topics at intervals, okay? It's not just, most times in most school timetable, mathematics is taught in the morning between the first 3 periods. On rare occasions, we see it in coming after break. If you have given that topic, if you have taught that concept in the morning, you can walk into the class at break time, tell them, what is this times this? What is this again? What's the formula for this again? Or you just write a question on the board and ask them, try this out. You could come back the next day, even if you don't have them, give them a question on that. Try this out. Let me see how much you're able to remember. By this repetition, you are able to make learning stick more in the minds of these learners, okay? There is no magic to having information move from short-term to long-term memory other than repetition, okay? And like I always tell my students, if you do not practice math, you will forget math, okay? That is why a lot of times we are able to remember all this secular music we learned when we were a child, or just songs that we knew from 10 years, 15 years ago. Let's say someone just starts to play it, you're able to remember all the lyrics. Why are you able to remember them? That's because you listen to it over and over and over again when it's rained. Okay, so if this knowledge is not repeated, if it is not used often, there is tendency that these children will forget, especially the ones that find math very boring. Give frequent practice activities to strengthen understanding, okay? Give frequent practice activities to strengthen understanding. Don't just give questions from one dimension. For example, you have taught simple interest, for example. They know how to find simple interest. You can also tweak it. How about if your interest is given and you're looking for your principal? What do you do? If you are giving rates, you have principal and interest and time, you are looking for if you are giving principal, interest and time, and you're looking for rates, what do you do? Okay. Remember I said earlier that you should teach them so many methods to solve these mathematics. You can even give them the rate formula, which is P times T. I times interest times 100 over P times T. Or you let them put the interest equal to whatever digits and the space of R blank, and they collect like terms to find their value. All right. Use quizzes and retrieval exercises to encourage recall. Use quizzes and retrieval exercises to encourage recall. There is this thing I do for my learners, okay? At intervals, sometimes I do it 2 weeks or 3 weeks. I just use ChatGPT to generate questions, age-appropriate questions on all the topics I've taught them in the term. And then we have a quiz competition. We just set out 1 mass period in the week for a quiz competition. I just share them at random. Okay, you pick one, number two, 1, 2, 1, 2, all the ones, one group, all the twos, one group. Or I could do it boys against girls, or I could do it those sitting on the left against those sitting on the right, just at random. And then I throw these questions to them. I see how well they're able to remember. Okay. Connect new learning to prior knowledge. This one is very, very important. And like I always tell my students, you cannot just teach one topic and let that topic lay at rest till when it's time for test or when it's time for exam. No. Relate one topic to another topic, okay? I taught fractions in my class in first term, but up till this third term, I'm still using the knowledge of fractions, okay? Percentages, decimals, these are all relative in most other topics. We learned what's average speed some weeks back. Then when you're dealing with average speed, you have to use fraction. When you're dealing with simple interest, you have to use fractions. You would even need decimal and percentages. So these are all relative, okay? As you teach this new topic and you're making reference to the old topic, you can quickly brush through for those students that may have forgotten. Brush through that old topic in maybe a minute or two, okay, and make sure that they've not forgotten the concept. Provide practical and engaging learning experiences. In this part, I cannot overemphasize this because, like the speaker yesterday talked about, these children need to be involved. They need to touch, they need to feel, they need to do. You can't say, oh, because math is not a regular subject that most students already have background knowledge of, so you will not allow the children to talk. You will not make it learner-centered. You will do more of the talking. They will get bored, though. That's why I have some children snoozing off in math classes. They would get bored. So how do you make your math classes practical? Before I start any new topic, okay, I tell my students the day before, tomorrow we are going to start learning, let's say, measures of central tendency. Go and make a research on that. And then when I come the next day, I hear what they have found out. I listen to them. I tell you, oh, what did you find out? What did you find out? And it's not just by telling me, oh, measures of central tendency are the mean, median, mode, and range. What are they about? What are they used for? Okay. Now, after engaging them in those conversations, I solve a question, an example question. We solve the mean, we find the mean, the median, the mode, and the range, and all of that. And after that, I will not tell them, imagine if a class of 20 pupils took a test and these are their scores. You have found the mean, the average, you have found all the averages. Would you, as a student, say that these children performed well or not? Let them think. Seeing all the averages we have calculated, can you see that this grade 5 class or this grade 6 class did well in math test? Let them think. Okay, now you're able to relate all that you have taught into practical experiences. And then they'll tell you, oh, since the mean is a 4.5 and the total of all the scores is 20, then they did bad because the average is so far from the total. You would even hear another person say, using the median score, the child in the middle score is about 10.5 out of 20. That means on a general, they performed on an average level. They didn't do so bad, but they didn't do so good at the same time. And then another person will tell you, oh, the range, I'll use the range. The highest score is a 19 over 20, and the lowest score is an 8 over 20. If I subtract these two, I have 11. There is a wide gap between the person that scored the highest score and the person that scored the lowest score. So, in my own opinion, they did not do so well. Engage these learners in conversation. Let them think, okay? There's nothing that gives me more joy as a math teacher than having children that are able to think, okay? We need to learn to teach children how to think, how to reason out problems on their own. And of course, you should encourage learners to explain concepts in their own word. I believe I've flogged a lot about this when I was explaining the previous points. Please, always make out time to listen to your children, okay? It is when you listen to them that you're able to know what is going on in their mind, whether they are following in what you're teaching or they are not, whether they are lost or they are with you. Okay, so these strategies help to transfer learning from short-term memory to long-term memory, improving retention and understanding. Okay, now let's talk about comprehension of word problem. This is where a lot of us math teachers find it difficult, okay? When I teach 1 plus 1, students know the answer. When I say what is 5 times 3, they know the answer. But when I tell you that in an egg tray, there are 5 rows of eggs and 3 columns of eggs, find the total number of eggs in the tray. Are they able to know what you're asking of them? This is a major problem that most math teachers face. So yes, we're going to talk about how to help learners comprehend and interpret word problem questions. Okay, a lot of learners make mistakes because they do not understand maths, the question on ground. I know my students recently wrote the National Common Entrance. That should be 2 Saturdays ago, last Saturday. Last Saturday. And one of the things that we struggled with while we were preparing is comprehension of problems. I know this Ugo that we practice with can be very tricky, okay? If you are not sure of what you are solving, you might solve the wrong thing. And whatever you are going to arrive at will be one of the options there. So if you are not careful, what has this question asked me to do? What did they exactly want from me? You might think that your wrong answer is the correct answer because it's in the option there. Okay, so in comprehension of word problem, you need to teach pupils to read their questions carefully. You need to teach your pupils to read their question carefully and then identify important information and numbers. It's as if they have to interpret the question first, okay? Because that interpreting is where there is always mistake. There's a question I gave my learners when we were talking about average speed. I told them this. The question is, I can't really remember the question, but I'll just, create something that looks like what it is. A school bus traveled from Kubwa to Lokogoma. I think the school bus left at around 7 a.m. and arrived at Lokogoma at 9 a.m. in the morning. If it covered a distance of, let's say, 470 kilometers, which is, unrealistic, but let's use 470. What is the average speed? In this case now, the children have to interpret the question. They know that to solve average speed, I need 2 things, distance and time. My distance is clearly written in the question, the 470 kilometers, but my time is between 7 a.m. and 9 a.m. What do they do? So they need to learn to read that question carefully, analyze the question. I'm solving for speed. The 2 things I need is distance and time. Where is my distance? Where is my time? Distance should be a digit, time should be a digit, but under time, I am giving 2 numbers. Let them go back and read that sentence again. It's left this at this time and arrived here at this time. They need to bring out a time from that situation. And of course, before you teach average speed, they should have learned time interval, time conversion, and all of that, okay, because it goes hand in hand. So they should be able to relate what they have learned and interpret that time. I know that, I need to first of all find the time interval. I can't just solve with 7 o'clock. I can't solve with 9 o'clock. And it will be meaninless to add 7 and 9 and say, my time is 16 hours or 16 whatever, okay? So after they identify these important information and numbers, then they determine what is being asked. Let them read the questions as much as 5 times, if that's what it to take them to understand, okay? After reading the question, then if they've now determined what it is they are being asked, then it will be easier for them to choose the correct operation. Am I going to multiply? If they're asking me to find the principal, do I multiply to get the principal? Do I do this? Do I do that? Okay, that stage of determining what is being asked and choosing the correct operation is where it is more technical, and they need to learn to get that right. Okay, and after they choose the correct operation, then they can go ahead and solve the problem. And of course, they can check their answer when they are done. I always advise students to check when they are done. If I've been asked to find, let's say, cost price, and I know that I'm looking for cost price when profit is given. I know that profit is selling price minus cost price. After finding my cost price, go and fit that cost price in the value of the formula and use the profit formula to check. If my profit says I subtract cost price from selling price, subtract it, will this give you that profit? If it does, then you know you're correct. Okay, so a useful strategy is the rucksack. I call it the rucksack. That is the read, understand, choose, solve, answer, and check. All right, please, if you're following, can I see a thumbs up? Okay, thank you. All right, let's talk about how we are going to help learners to improve mathematical accuracy. How do we help learners to improve their mathematical accuracy? Number one, develop strong number facts and timetables. I remember the speaker for yesterday spoke about memorizing timetable, and we know that it is something that is very hard for children to do, but it's not impossible. Okay, it is not impossible because there are actually some multiplication table that you can't use. You can, but it will take you a longer time if you want to use repeated addition to find out. For example, you are doing 6 times 12. So you have to count 6 12 times. When you're solving you have a whole lot of other questions to solve. That would be a waste of time. So they can always learn their multiplication table. There are some basic skills that I expect any child in math class to know. Number one is multiplication table. Okay, multiplication table. We have number facts. For example, what are the number pairs that make up 10? If I have 7, what's the other one going to be? 3. Or what are the number pairs that make up 100 or make up 50? Or I'm telling you things like double 200, reduce 50 by half. That kind of thing. They should be able to know the answer at the tip of their finger in key stage 2. Okay. Then encourage pupils to always show they are working. I also have this rule in my math class that if you just give me an answer without solution, you have half mark. Okay, if I ask you to find the speed of whatever moving vehicle, and you just go and write the speed is 5 kilometers per hour, I'm going to ask you, how did you get this to 5 kilometers per hour? What's your proof that I did not do a magic or that I did not copy someone to get this answer? I need to see it shown there. I need to see your formula first of all. Then I need to see how you're able to pick digits from the question into the formula and how you solved it. You don't have to show me how you're able to divide your 200 by 5 or whatever it is you're dividing. No, I don't want to see that part. But show me how you interpreted your question. Show me the formula. These are the workings that makes me understand. And there is this thing I do when I give children question, when I give them task, right? And I noticed that at this stage of this topic, you're expected to have gained, or I know that you have gained 50 to 60 or 70% mastery in this topic. And then you're bringing a task to me, and then I see that you got it wrong. I watch your thought process. Where did you mix it up? Where did you get it wrong? If it is in a place you ought to multiply and you added, or a place you ought to divide and you subtracted, or let's say in the course of your division or in the course of your multiplication, say you are dividing 20 by 5 and you stroke out the 5, you stroke out 20 and you're getting a 5 instead of a 4. I won't even say anything. I'll just write redo. You will go back and figure out your mistake, okay? By so doing, you help children to know that they are supposed to go through their work when they finish before they go and submit to you or before they submit it to whoever that is marking, okay? That's where you are able to train them to work independently. Even if you're not there and someone else is administering your test or your exam, they're able to know that whenever I finish, I should go through my work, okay? Because I won't mark that half and tell you, oh, half mark. In exam, you can't do that, okay? If you're marking an exam, but if it is class task, I will send you back, or you will still go back and redo it. You figure out your mistake yourself, except if I'm in very good mood, then I'll just circle out where the mistake is coming from and ask you to go and redo it. So please, always encourage them to go through their working after they finish, before they submit. They should use self-checking and inverse operations. Self-checking and inverse operations, especially in quantitative reasoning. Okay, I know a lot of children find quantitative reasoning difficult, especially when it comes to grade 5, grade 6 level of quantitative reasoning, like the ones in our lantern QR. Let's say if you have a triangle and then to get the digits on top, you have to double the digits at the left side and add the digits on the right side. If you're now asked to find that digits on the right side, what do? They should be able to inverse the operation. If I have doubled to get this, what do I do? If you have doubled 5 and you doubled 5, that gives you 10, and you've subtracted 2 or you added 2 from it to get the number on top. Double 5, that's 10. Okay, to get the number on top, and that is 12. Where you're asked to look for that 2, what do? You need to double that 5 and subtract it from the 12. That is inversing operation. Okay, so the children need to be able to, it's just a thing of gaining full mastery, having ground knowledge in what you're doing, knowing why you are adding at this stage, why you're subtracting on this stage. Of course, they should know that the opposite of plus is minus. Opposite of multiplication is division. Okay, if I have squared the number to get that, the opposite is going to have to be square root, things like that. And they should be able to analyze their mistakes. When I said earlier about sending children back to go and redo a task that they've gotten wrong, I'm sending you back not because I want to punish you, but I want you to go back, look at what you have done, find out where there is error, and be able to correct that mistake. It helps you gain more mastery in that topic. Okay, I know there are even some times when a child brings a question to me, and then let's say I'm so busy at the moment, I'll just tell you, oh, go and meet this person. And that person that I've told you to go and meet will be able to check that work and be able to spot if there's an error in it. And sometimes I'll even ask another person to go and meet you. You don't have to be the best in my math class for me to send someone to you. No. You don't have to be, might even be the child that is the weakest in my math class. But me sending someone to you will make you have a sense of responsibility that, yes, my teacher trusts me. So I need to figure out if there is a mistake in this thing that this person has solved. That is how you make children gain ground knowledge in whatever topic you are teaching, and it improves their accuracy. Okay. And there's also this part where I tell my students to solve multiple times, especially in tests and exams. Okay, you have finished solving. How do you go over your work in math? It is not by looking at it. It is not English. It's not social studies. It's not history. You go over it by resolving again. Okay, and if you solve the second time, you're getting an answer that is different from what you got the first time. What do? Solve the third time. Solve the fourth time. That is how you ensure accuracy. All right. Provide regular practice opportunities. Let your children practice regularly. I know a lot of schools, they do math every day, but that doing math once a day, most of the time doesn't really help. There was a day I gave my students this analysis. We have math once a day, and that's a period of 40 or 45 minutes for some schools. Now, you have 8 hours of learning in school. You spend just 45 minutes or 40 minutes of it learning math. And you're not going to learn that math again until the next day. 24 hours in a day, 40 minutes spent on math. How do you hope to become better at it? So they need to learn to practice and practice and practice regularly, okay? Me as a person, I love math and I love to engage my students a lot in math. Currently, some of my students have exhausted 4 notebooks. You see their math note is as big as, because they practice a lot. I mean, you just have to practice. If you have a free period or there's a teacher not coming in, or sometimes I know that you don't even have a free period, I'll just give you 1 or 2 questions to solve whenever you're free. I'll tell you that I'll check it 2 days later. Solve that question and show it to me. And please, whenever I give questions like that, always ensure to go back and correct it or discuss it with them. If not, next time when you give them, they won't bother solving it because they know that you won't even make reference to it again. Accuracy grows when pupils work carefully and they develop good mathematical habits. Accuracy grows when pupils work carefully. That's what carefully, and developing good mathematical habits are keywords in that sentence rather. Okay, they need to learn to solve with caution. But that doesn't mean that speed is going to be out of it. No. There are times when I give my students timed assessments, okay, especially when it is diagnostic assessment. I could just come into the class one day on a day that I'm in a good mood, I write out 10 questions and I tell you have 7 minutes. Of course, it has to be a topic that you have gained mastery in. Okay, that is me just checking out for speed. I tell them you have 7 minutes, and at exactly 7 minutes, I'm going to collect it, whether you're done or not. Okay, and it's in cases like that I would always award stickers to those that finish within time, and also those that had the highest score within that time frame. So by doing all of this, there is an improvement in accuracy and also in speed. All right, that brings us to the end of our class this evening. Our conclusion: teaching mathematics in Key Stage 2 should focus on developing confident, curious, and capable learners through practical learning. The CPA approach, that is concrete, pictorial, and abstract approach. Through practical learning, the CPA approach, educational theories, engaging teaching method, effective problem-solving strategies, and a focus on accuracy, teachers can help pupils to build strong mathematical foundations and a lifelong appreciation for mathematics. Thank you very much for listening. That will be the end of our topic. Thank you.
Thank you so much, Miss Epube. Thank you so much.
You're welcome.
You just made me had me take a look into my daughter's math classroom and have an idea of what she's doing. Thank you so much for this. Before I ask my question, this let's see your pretty face now. Before I ask my question, does anyone have any question? Any questions? No questions. Okay. So I'm going to ask this, Ms. Ebube. I have a parent
Okay.
here. She happens to be a teacher, a science
Okay.
teacher
Okay.
that hates math.
Oh, the teacher herself, the parents herself.
Yes, she's a
Okay.
teacher. She's in the sciences,
Okay.
but she dislikes math. So, if her, how would you advise her to? What would you advise her to do if a learner in her basic science class, for instance, approaches her with a math question that she didn't quite understand with the when the math teacher taught, and she really doesn't like the math teacher? This child approaches her and to ask this question: what would you advise this teacher to do? If not the child, what if her own child comes home and say, "Mommy, my teacher gave me this homework. I've tried and I can't do it." What would you advise this teacher?
Okay, thank you very much, Ms. Raina, for that question. Okay, math is a subject that is quite dicey. Okay, it's unlike other subjects that almost everybody has a knowledge of. Okay, mathematics in Key Stage 2 can be tricky. Okay, because that's where you move to harder topics. All right. Now, if you're a parent or if you're a teacher that his child has brought a question to you that they do not understand, in that case, please be honest with that child rather than teaching that child the wrong thing or the wrong concept. Okay, be honest with that child. This can be shameful, I know, but it is better than teaching that child the wrong thing. Okay. And these children nowadays, they are very smart. If you're telling them, okay, let me look at the example, let's see, they already know. They already know that you don't have an idea. Okay. But if it is something that you can take a look at the example in the textbook, or you're able to get information online, then fine and good. And you should be able to explain it to that child that, okay, this is what was done, or this is what you have to do to get the answer. But please don't go to ChatGPT. Please don't go to ChatGPT. It is going to explain the concept in a very long way, and it's even harder to understand that way. Okay, you know, math is meant to be solved in stages. Okay, we solve from this to this. You don't say 2/5 times 100/1 equals to this, equals to this, equals to this in one line. No, when you solve stage 1, you go to the next line, you solve, next line, you solve. But ChatGPT will just totally confuse the child. I've seen children I give math assignments to, and then they come back with their, once I look at the solution, I know that this is ChatGPT. Then you just see them look at me this way, they'll be staring. I say, this is ChatGPT. They'll be like, yes, why did you use ChatGPT? For me, it's better that child returns that assignment to their teacher and tell the teacher that, oh, I don't understand. Because when I give you assignments, I want to know what you're able to remember after hours away from the time I taught you. I want to see how well you're able to remember this concept in 5 hours time when you get home. Okay, so if you're not able to remember it, it helps me to know where you are at. Okay, and then I know how to help you as a student. So there's nothing wrong with returning that assignment back to the teacher.
All right. Thank you very much. So the lady in question, the teacher in question, I hope you heard what Miss Faith said. I'm not going to call your name, you know yourself. All right. Is there any more question? Does anybody else have question? Any question for Miss Epupe? For Miss Faith, sorry, I called her. That's what I call her, Epupe. So, any question for Miss Faith? So, I don't think there's any. That means you overtaught. You did justice to the
Thank
topic.
you.
Thank you so
Thank
much
you.
for your time, Miss Faith. God bless you. The
Thank you.
person clapping, 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 Miss Ursula. We are having Miss Ursula next week for learning math in secondary school, for secondary school math. Yes, so we're all invited next week, Saturday, for the meeting. So thank you, everybody. Invite someone. Hopefully the link will be up soon for that of today, yesterday, and next week. I've had issues trying to download it. I believe I've been able to rectify it. So I will share the link for those that want to revisit. Thank you all so very much. Thank you so much for sparing your 1 hour for me. God bless you. We can all unmute to say our goodbyes and to thank Miss Faith.
Bye. Good night. Thank you very much, Miss Faith.
Thank you too. You're welcome.
Thank you, everybody, and goodbye. God bless us all.